And now in this lecture we'll answer two questions. In the first question we find out the radius of this circle, and in the second question we find out the area of this semicircle APQB. So let's start with the first question. In the domain we have a circle. This is line segment CP, this is equals to 12 units in its length. This is line segment AP, this is equals to 3 units in its length. This is line segment PB, this is equals to 4 units in its length. This is angle CPB, this is equals to 60 degrees inside. Again, our test is to find out the radius of this circle. So first of all, it is given us the equation that A and B is a straight line. So if you focus on the upper side of the straight line A and B, it's point P. Here the sum of the areas must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the areas on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line A and B, it's point P. We have this angle that is equals to 60 degrees in size, plus this missing angle. The total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 120 degrees in its size. In the next step, we will join point C and A together by a straight line. We will join point C and B together by a straight line. And doing those constructions, we consider three triangles. Those are the two small triangles and the big triangle, triangle ABC, that consists those two smaller triangles. So in the next step, so we will implement the law of cosines on all those three triangles. So first of all, we will implement the law of cosines on this grand triangle, triangle APC. So a bit quickly on the law of cosines. The law of cosines is true in any triangle. So this is triangle ABC, that could be any triangle. Side AB equals to units in its length, side AC equals to B units in its length, side BC equals to C units in its length. This is angle BAC, that is equals to theta degrees in its size, according to our definition. So in this triangle ABC, that could be any triangle, according to the law of cosines, the following equation is true. C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, C square equals to A square plus B square minus 2 times A times B times cosine theta. So you can actually implement the law of cosines in our drawing. We implement the law of cosines on this grand triangle, triangle CAP. So according to the law of cosines, on the grand triangle, triangle CAP, the following equation is true. We choose angle theta is this angle APC, this is equals to 120 degrees in its size. So according to the law of cosines, in this triangle, grand triangle APC, the following equation is true. CA square equals to AP square plus CP square minus 2 times AP times PC times cosine 120 degrees. And again, in this triangle ACP, according to the law of cosines, the following equation is true. CA square equals to AP square plus CP squared plus 2 times AP times PC times cosine 120 degrees. CA is the missing side, so we leave it as it is, so it is CA squared equals to AP squared. AP is 3, therefore AP squared is 3 squared, that is 9. Plus CP squared. CP is 12, therefore CP squared is 12 squared, that is 144. Minus 2 times AP, that is 3, times PC, that is 12, times cosine 120 degrees. Cosine 120 degrees is equal to minus 1/2. So in total, we should find out that CA squared equals to 9 plus 444, that is actually 153. Here we have minus times minus is plus. So this expression is a positive expression. We have 2 in the numerator, 2 in the denominator, so 2 get cancelled. In total, we should know that this expression equals to 3 times 12, that is 36. So in total, we should know that CA squared equals to 153 plus 36, that is 189. Repeat again, CA squared equals to 189. Here we take a look out of this equation, finding out that CA equals to the square of 189 units in its length. This is the missing side CA. This is equals to square root of 189 units in its length. So, okay, now. And CA squared equals to 189. Likewise, we will implement the law of cosines on this right triangle CPB. The right triangle CPB, according to the law of cosines, we choose angle theta as this angle CPB, that equals to 60 degrees in size. So according to the law of cosines, on the right triangle CPB, the following equation is to CB squared equals to PB squared plus CP squared minus 2 times PB times PC times cosine 60 degrees. Repeat again, in the right triangle PCB, according to the law of cosines, the following equation is to CB squared equals to PB squared plus CP squared minus 2 times PB times PC times cosine 60 degrees. CB is the missing side, so we leave it as it is, so it is CB squared equals to PB squared. PB is 3, therefore PB squared, PB is 4, therefore PB squared is 4 squared, that is 16. Plus CP squared. CP is 12, therefore CP squared is 12 squared. 12 squared, it is 144. Minus 2 times PB. PB is 4. Times PC. PC is 12. Times cosine 60 degrees. Cosine 60 degrees is 1/2. So in total, we found out that CB squared equals to 16 plus 144. This is actually 160. Minus, here we have 2 in the numerator, 2 in the denominator, so 2 get cancelled. And we're left only with minus 4 times 12, that is minus 48. So in total, we found out that CB squared equals to 160 minus 48, that is 112. Repeat again, CB squared equals to 112. Here we take root out of this equation. And finally we get that CB equals to the square root of 112 units in its length. This is side CB, that is equals to the square root of 112 units in its length. And we already found out that CB squared equals to 112. So we know CB squared equals to 112. In the next step, we'll implement, first of all, we'll define this angle. This is angle CAB. This angle is alpha. And we'll implement the law of cosines on this big triangle, triangle ABC. And we'll choose angle theta as alpha. Angle theta equals to alpha. Angle theta in the law of cosines equals to alpha, according to our choice. And we get that while ABC according to the law of cosines, the following equation is true. CB squared equals to CA squared plus AB squared minus 2 times CA times CB times cosine alpha. Because again, in this triangle ABC, the big triangle ABC, according to the law of cosines, the following equation is true. CB squared equals to CA squared plus AB squared minus 2 times CA times CB times cosine alpha. We already found out that CB squared equals to 112. And it is equals to CA squared. CA squared is 189. Plus AB squared. AB is AP, that is 3, plus PB, that is 4. So AB in total is 7. Therefore AB squared is 7. AB squared is 7 squared, that is 49. Minus 2 times CA. CA is equal to 189 times CB. CB is equal to 112 units in its length. Actually, it is times AB, of course. But again, actually, this triangle ABC according to the law of cosines, the following equation is true. CA squared equals to AB squared, CB squared equals to CA squared, plus AB squared, minus 2 times CA times AB times cosine alpha. So AB is 7, AB is 7, so AB by 7 times cosine alpha. So in total, we actually found out that this triangle ABC, according to the law of cosines, the following equation is true. 112 equals to 189 plus 49 minus 2 times 7 times square root of 189 times cosine alpha. 189 plus 49 is 233. 189 plus 49 is 238, of course. So 112 equals to 238. Minus 2 times 7 is minus 14. So in total this expression equals to minus 14 times square root of 189 times cosine alpha. So in total, if you found out that 112 equals to 238 minus 14 times square root of 189 times cosine alpha. Here we subtract 112 from this equation. So in this side of the equation we left with nothing, that is to say 0. While on the other side of the equation we have 238 minus 112 is 126. Here we have minus 14 times square root of 189 times cosine alpha. So here we'll add to this equation 14 times square root of 189 times cosine alpha. That is why we move this expression to the other side of the equation. And we get that 126 equals to 14 times square root of 189 times cosine alpha. So here we will divide this equation by 14. And 126 over 14 is 9. So in this of the equation we have 9. Equals, here 14 over 14 is 1, so we left only with square root of 189 times cosine alpha. So in total we found out that cosine alpha times square root of 189 equals to 9. So here we will divide this equation by square root of 189. And get that cosine alpha equals to 9 over square root of 189. So here we will substitute 189 by 9 times 21. So we get that cosine alpha equals to 9 over 9 times 21. Here we take 9 out of the root. So this expression equals to 9. And the square root of 9 is 3. Inside the root we left only with 21. So in total we actually found out that cosine alpha equals to 9 over 3. We have 9, we divide this expression by 3, both of the numerator and the denominator of this expression by 3. So 9 over 3 is 3 over, and 3 over 3 is 1. So in the denominator we left only with square root of 21. So in total, we actually found out that cosine alpha equals to 3 over square root of 21. Repeat again, cosine alpha equals to 3 over square root of 21. In the next step, we implement the trigonometric identity TA is a version for trigonometric identity. We implement the following trigonometric identity in our question. The trigonometric identity is as follows: sinus square alpha plus cosine square alpha equals to 1. So here we subtract cosine square alpha from this trigonometric identity, and we get that sinus square alpha equals to 1 minus cosine square alpha. So here we take out all of this equation, and finally get that sinus alpha equals to the square root of 1 minus cosine square alpha. So in total we should find out that sinus alpha equals to the square root of 1 minus cosine square alpha. We already found out that cosine alpha equals to 3 over square root of 21. We'll copy this equation here. Cosine alpha equals to 3 over square root of 21. So here we'll square both sides of this equation, and we get that cosine square alpha equals to 3 squared, that is 9, over square root of 21 squared, that is 21. So in total we should find out that cosine square alpha equals to 9 over 21. So now we can substitute cosine square alpha in this equation by 9 over 21. We do it now, and we get that sinus alpha equals to the square root of 1 minus cosine square alpha. Cosine square alpha is 9 over 21. So in total we should find out that sinus alpha equals to the square root of 1 minus 9 over 21. Here we will multiply 1 by 21, and then we will divide it by 21 in order to overcome the factor of this number, and we get that sinus alpha equals to the square root of 21 times 1 is 21 minus 9 over 21. We multiply 1 by 21 and we divide it by 21, so we change nothing. It is allowable to multiply anything by 1. So in total we found out that sinus alpha equals to the square root of 21 minus 9 is 12 over 21. Here we divide both the numerator and the denominator of this number by 3. We get that 12 over 3 is 4, and 21 over 3 is 7. So in total we should find out that sinus alpha equals to the square root of 1 over 7. We take 4 out of the root. The square root of 4 is of course 2. So inside the root we have to leave 7. So in total we should find out that sinus alpha equals to 2 over square root of 7. And we already found out that CB equals to square root of 112 units in its length. In the next step, we will implement the law of sines on this triangle ABC. Okay, again, we will implement the law of sines on this triangle ABC. The law of sines is true in any triangle. This is triangle ABC that could be any triangle. The length of side AB is equals to 3 units in its length, side AC equals to B units in its length, side BC equals to 1 unit in its length. And this is again BAC. This is equals to capital A degrees in size. This is again ABC. This is equals to capital B degrees in size. And this is again ACB. This is equals to capital C degrees in size. And this triangle ABC is described by this circle, and the radius of this circle is R. So according to the law of sines, in this triangle ABC that could be any triangle, the following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. Okay, again, according to the law of cosines, the following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks this triangle ABC. So we can implement the law of sines. Now we're going. This is triangle ABC. Triangle ABC is blocked by this circle. Why triangle ABC is blocked by this circle? Because of the fact that all the three vertices of this triangle ABC lie on the circle itself. So we can implement the law of sines in this triangle ABC. Actually, we can implement the law of sines in any triangle, but if you want to implement the law of sines on a triangle that is blocked by a circle, the triangle must be blocked by the circle, of course. That is to say, all the three vertices of the triangle must lie on the circle itself. You see that all the three vertices, A, B, and C, lie on the circle itself. So this is triangle ABC that is inscribed by this circle. So you can implement the law of sines in its full version on this triangle ABC. So according to the law of sines in this triangle ABC, the following equation is true. CB of sinus alpha equals to 2r. Again, CB of sinus alpha equals to 2r, and r is the radius of this circle. That is the radius that you are looking for this question. So according to the law of sines, the following equation is true. In triangle ABC, CB over sinus alpha equals to 2r. In triangle ABC, according to the law of sines, the following equation is true. CB over sinus alpha equals to 2r. CB over sinus alpha equals to 2r. Again, r is the radius of this circle that blocks triangle ABC. That is the radius that you are looking for this question. You have to find out the radius of the circle. So CB over sinus alpha equals to 2r. We find out that CB equals to the square root of 112 and sinus alpha equals to 2 over square root of 7. So we just substitute CB by square root of 112. This equation, and we substitute sinus alpha by 2 over square root of 7, and it's equals to 2r. R is the radius of the circle that blocks triangle ABC. This is the radius that you are looking for in this question. So here we have square root of 112. We substitute 112 by 7 times 16. Which is 112 is 16 times 7 over 1 over 2 over square root of 7 equals to 2r. The square root of 16 is 4, so we'll take 16 out of the root, so inside the root we'll have to only with 7. So it is 4 times square root of 7 or 2 over square root of 7 equals to 2r. Here we remove square root of 7 to the numerator and 2 to the denominator. In total we get that 4 times square root of 7 times square root of 7 over 2 equals to 2r. 4 over 2 is 2. So it is 2 times square root of 7 times square root of 7 equals to 2r. Here we divide this equation by 2. So finally we found out that r, that is the radius of this circle, that is the radius that we are looking for in this question, it is equals to the square root of 7 times square root of 7 is 7 units in its length. And that is the answer to the first question. So in the next step, I will present you the second question of this lecture. And so the second question. Our task in the second question is to find out the area of this semicircle APQB. And again, our task is to find out the area of this semicircle APQB. So in the domain we have a semicircle, and this is line side PC is equals to 21 units in itself. This is line side PQ is equals to 16 units in itself. This is line side AC, this is equals to 7 units in itself. This is again CPQ, that is the right again. Again, our task is to find out the area of this semicircle APQB. We define the radius of the semicircle as x. Therefore, the diameter AB is 2x. AB is 2x. What is the length of this line segment CB? From the drawing it is very easy to see that CB in total equals to AB minus AC. Okay. CB equals to AB minus AC. So CB equals to AB is 2x, it is the diameter of the circle, minus AC. AC equals to, is equal to 7 units in itself, according to what is the answer question. So in total, we actually found out that CB equals to 2x minus 7 units in its length. This is not CB, is equals to 2x minus 7 units in its length. In the next step, we will complete this semicircle to a circle. So we completed the semicircle to a circle, and we'll extend line segment PC by straight line until it touches the circle. We define the touching point of the extended line segment PC with this circle. This point is point M. Likewise, we define the length of this line segment CM as A. So here we can implement rule 65 in our circle. So I'm pretty quickly on rule 65. Rule 65 is true in any circle, so this circle could be any circle. So in any circle, if chord AB intersects with chord CD at point O, then the following equation is true. AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. Repeat again with the rule. In the drawing you have a circle. This is chord AB that intersects with chord CD at point O. So whenever you have two chords that intersect with each other inside the circle, the following equation is true. AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can actually implement rule 65 in our drawing. Well, because in our drawing, this is chord AB that intersects with chord PM at point C. Again, chord AB intersects with chord PM at point C. So write it down. Chord AB intersects with chord PM at point C. Intersection point of chord AB with chord PM occurs at point C. Repeat again. Now we're going. Chord AB intersects with chord PM at point C. So all the requirements for rule 65 are satisfied, therefore we can implement rule 65. According to rule 65, the following equation is true. AC times CB equals to PC times CM. Again, AC times CB equals to PC times CM. So write it down. According to rule 65, the following equation is true. AC times CB equals to PC times CM. This equation is the implementation of rule 65 in our circle. AC is 7 times CB. CB is 2x minus 7. And is equals to PC. PC is 21 times CM. CM equals to units in itself according to our definition. So in total we found out that according to rule 65, 7 times 2x minus 7 equals to 21a. Here we'll divide this equation by 7. And we get that here 7 will get cancelled and left only 2x minus 7 equals to 21a over 7 is 3a. So in total we found out that 2x minus 7 equals to 3a. Here we'll add 7 to this equation. And we get that 2x equals to 3a plus 7. And again, in total we found out that 2x equals to 3a plus 7. In the next step, we will join points Q and M together by side line. By joining points Q and M, we created the right triangle QPM. And again, by joining points Q and M together by side line, we created the right triangle PQM. This is peripheral MPQ, that's subset of chord QM. Again, peripheral MPQ or QPM, subset of chord QM, and it's equals to 90 degrees in its size, according to what is given as a question. So here you can implement rule 5. Now drawing, repeat quickly on rule 5. According to rule 5, any peripheral angle that is equal to 90 degrees in its size are subset of the diameter of the circle. So in the drawing, we have a circle. This is triangle MAN. That is equals to 90 degrees inside. And therefore, according to this rule 5, triangle MAN must subset of the diameter of the circle. Triangle MAN subset of chord MN, and chord MN is indeed the diameter of this circle. So according to this rule 5, any triangle that is equals to 90 degrees inside, that this triangle MAN must subset of the diameter of the circle. We can definitely implement rule 5 in our drawing. Because in our drawing, this is triangle QPM. This is equal to 90 degrees inside, and therefore, according to rule 5, it must subset of the diameter of the circle. Triangle QPM subset of chord QM, therefore chord QM must be the diameter of the circle according to rule 5. Because I know that chord QM is the diameter of this circle. The diameter of the circle is 2x. Therefore, QM equals to 2x units in itself. So in the next step, we'll implement the Pythagoras theorem on this right triangle PQM. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Repeat again. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right triangle PQM, QM is the hypotenuse, therefore according to the Pythagoras theorem, QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. So I denote here by PT is the progression for Pythagoras theorem. So QM square, that is the square of the hypotenuse, is equal to PQ square plus PM square. And again, according to the Pythagoras theorem, on this grand triangle PQM, QM square, that is the square of the hypotenuse, equals to PQ square plus PM square. QM is 2x, therefore QM square is 2x square. And it equals to PQ square. PQ is 16, therefore PQ square is 16 squared, that is 256 plus PM square. PM in total it is PC, that is 21, plus CM, that is 8. So in total PM equals to 21 plus A units in its length. Therefore, PM square is 21 plus A square, 21 plus A square. And again, PM total equals to 21 plus A squared. So in total, according to the Pythagoras theorem, the grand triangle QPM, the following equation is 2x squared equals to 256 plus 21 plus A squared. We already found out that 2x equals to 3a plus 7. So we substitute 2x in this equation by 3a plus 7. 2x equals to 3a plus 7, therefore 2x squared equals to 3a plus 7 squared. And it equals to 256 plus 21 plus A squared. Here we'll open the brackets on both sides of this equation and get that 3a plus 7 squared equals to 3a squared. It's actually 9a squared plus 7 squared, that is 49, plus 2 times 3a times 7 Actually 2 times 3 is 6 and 6 times 7 is 42. So this is 2 times 3 times 7 is 42a. So this plus 42a equals to 256, and we have plus 21 plus a squared. 21 plus a squared equals to 21 squared, that is 441, plus a squared, plus 2 times 21 times 8, that is 42a. So here we have 42a on both sides of this equation, so 42a will get cancelled. After cancel 42a, this side of the equation we'll have to leave 9a squared plus 49 equals to 256 plus 441 equals to 697 plus a squared. Here we subtract a squared from this equation. If I get it 9a squared minus a squared is 8a squared plus 49 equals to 697. Here we subtract 49 from this equation and we get that 8a squared equals to 697 minus 49 equals to 648. So in total we found out that 8a squared equals to 648. Here we divide this equation by 8 and finally get that a squared 8a squared over 8 is a squared equals to 648 over 8 is 81. So in total we found out that a squared equals to 81. Here we take out of this equation and finally get that a equals to the square root of 81, that is 9. So a equals to 9 units in itself. This is 9 7 CF equals to 8, a equals to 9 units in itself. So CF equals to 9. And our task is to find out the area of this semicircle APQB. So here we already found out that two x equals to 3a plus 7. So let's put this equation here. Two x equals to 3a plus 7 according to what we already found out. So 2x equals to 3a. A is 3, so 3a is 3. A is 9, so 3a is 3 times 9, that is 27, plus 7. So in total we found out that 2x equals to 27 plus 7, that is 44. That is 34. So 2x equals to 34. Here we divide this equation by 2 and finally get that x, that is the radius of the semicircle, that is the radius that we are looking for this equation, is equals to 34 over 2 is 17. So the radius of this semicircle, x equals to 17 units in its length. Our task is to find out the area of this circle APQB. Actually, we know that the area of any semicircle is equal to pi times the radius of the circle squared over 2. Therefore, the area of this semicircle must be equal to pi over 2 times the radius of our circle, that is x squared. So it is pi x squared over 2. The area of this semicircle, that is the area that we are looking for this equation, is equal to pi x squared over 2 square units inside. But we already found out that x equals to 17, so it is pi over 2, x is 17, therefore x squared is 17 squared. So in total we found out that the area of this semicircle, that is the area that we are looking for this equation, is equal to pi over 2 times 17 squared. So it is pi over 2, 17 squared is 289. So in total we found out that the area of this semicircle equals to either 289 times pi over 2 square in size in terms of numbers. This expression equals to 453.96 square in size. And again, the answer to this question is that the area of this semicircle AP cubed is equal to either 289 times pi over 2 square in size, or in terms of numbers, the area of this semicircle is equal to 453.96 square in size. So we finished to answer the second question. The next step, some of the lecture, start with the repetition of the solution of the first question, then repeat on the solution of this second question. Our task in the first question is to find out the radius of this circle. So in the drawing we have a circle. This is line segment PC, it equals to 12 units in length. This is line segment AP, it equals to 4 units in length. This is line segment PB, it equals to 4 units in length. This is again CPQ, it equals to 60 degrees in size. Again, our task was to find out the radius of this circle. So first of all, we know that AB is the side line according to what is given as a question. So if you focus on the upper side of the side line AB at point B, the sum of the angles must be equal to 180 degrees according to all three. So which angles we have at the upper side of AB at point B? We have this angle that is equal to 60 degrees in size. Plus this missing angle, total the sum of those two angles must be equal to 180 degrees according to all three. Therefore this missing angle must be equal to 120 degrees in size according to all three. Because again, we should find out that this is the missing angle APC is equal to 120 degrees inside according to all three. So in the next step, we join point C and A together by side line, we join point C and B together by side line. When doing these constructions, we're going to do three triangles. Those are the two smaller triangles, and the third triangle is the big triangle ABC that consists those two triangles. Consists those two right triangles. Those two triangles. So in the next step, we will implement the law of cosines on all those three triangles. The green triangle ACP, the white triangle CBP, the big triangle ABC. So repeat quickly on the law of cosines. Actually, the law of cosines is drawn in any triangle. So this is triangle ABC that could be any triangle. The length of side AB is C, side AC equals to B units in length, side BC equals to A units in length. This is angle BAC, that equals to capital A degrees in size according to our definition. This is angle ABC, that equals to capital D degrees. This is angle ACB, that equals to capital C degrees according to our definition. This is triangle ABC that is described by this circle, and the radius of this circle is R. So according to the law of sines, the following equation is 2. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that draws triangle ABC. Repeat again, according to the law of sines, the following equation is 2. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. So we can actually implement the law of sines in our drawing. So actually we implement the law of sines later on triangle ABC. Repeat again, we implement the law of sines on this triangle ABC later, but first of all, we'll implement the law of cosines on the green triangle, on the white triangle, on the big triangle ABC that consists of two smaller triangles. So I'm clicking on the law of cosines. This is triangle ABC that could be any triangle. Side AB equals to units in itself, side AC equals to B units in itself, side BC equals to C units in itself. This is again BAC that equals to 30 degrees inside according to our definition. So in this triangle ABC that could be any triangle, according to the law of cosines, the following version is true. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Repeat again. According to the law of cosines, in this triangle ABC, that could be any triangle, the following equation is true. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. So we can actually implement the law of cosines on this green triangle CAP. According to the law of cosines, in this triangle CAP, we should angle theta is this angle APC equals to 120 degrees in size. So according to the law of cosines, in this triangle ACP, the following equation is true. AC squared equals to AP squared plus PC squared minus 2 times AP times PC times cosine 120 degrees. Repeat again, according to the law of cosines, in this triangle ACP, the following equation is true. AC squared equals to AP squared plus PC squared minus 2 times AP times PC times cosine 120 degrees. CAP according to the law of cosines, CA squared equals to AP squared plus CP squared minus 2 times AP times PC times cosine 120 degrees. CA is the missing side, so we leave it as it is. So it's CA squared equals to AP squared. AP is 3, therefore AP squared is 3 squared, that is 9, plus PC squared. PC is 12, therefore PC squared is 12 squared, that is 144. Minus 2 times AP, that is 3, times PC, that is 12, times cosine 120 degrees. Cosine 120 degrees equals to 1/2. So in total, we found out that according to the law of cosines, in this rectangle APC, the following equation is true. CA squared equals to 9 plus 144 minus 2 times 3 times 12 times minus 1/2. So CA squared equals to 9 plus 144 is 153. We have here minus times minus is plus, so this expression in total is a positive expression. And we have 2 in the denominator, 2 in the denominator, so 2 get cancelled. So we left only with 3 times 12, that is 36. So it is plus 36. And 153 plus 36 is 189. So in total, we found out that CA squared equals to 189. Here we took out of this equation, we found out that CA equals to the square root of 189 units in its length. This is side CA, that equals to the square root of 189 units in itself, and CA squared equals to 189, of course. The next step, we implemented the law of cosines on this white triangle CBP. We choose angle theta, this angle CPB equals to 60 degrees in size. So according to the law of cosines, in this white triangle CPB, the following equation is true. CB squared equals to CP squared plus PB squared minus 2 times CP times PB times cosine 60 degrees. Repeat again, this triangle ABC, PBC, the white triangle PBC, according to the law of cosines, the following equation is true. CB squared equals to CP squared plus PB squared minus 2 times CP times PB times cosine 60 degrees. The white triangle CBP, according to the law of cosines, the following equation is true. CB squared equals to PB squared plus CP squared minus 2 times PB times PC times cosine 60 degrees. CB is the missing side, so leave it as it is, and it equals to PB squared. PB is 12, therefore PB squared is 12 squared, that is 149, plus PB squared. PB is 4, therefore PB squared is 4 squared, that is 16, minus 2 times CP, that is 12, times PB, that is 4, times cosine 60 degrees. Cosine 60 degrees is 1/2. So in total, according to the law of cosines, in this white triangle CBP, the following equation is true. CB squared equals to 16 plus 144 minus 2 times 4 times 12 times 1/2. 16 plus 144 is 160. We have 2 in the denominator, so 2 get cancelled, and we have to leave minus 4 times 12, that is minus 48. So total, if you want to know that CB square equals to 160 minus 48, that is 112. Again, CB square equals to 112. Here we took out of this equation, we found out that CB equals to the square root of 112 units in itself. This is, let me say, inside CB, that equals to 112 units in itself, and CB square equals to 112. The next step, we define this angle BAC is alpha, and we implemented the law of cosines in this triangle, the big triangle ABC. We choose angle theta in the equation of the law of cosines as alpha. So in this big triangle ABC, according to the law of cosines, the following equation is to CB square equals to CA square plus AB square minus 2 times CA times AB times cosine alpha. But again, this triangle ABC, according to the law of cosines, the following equation is to CB square equals to CA square plus AB square minus 2 times CA times AB times cosine alpha. And again, triangle ABC, according to the law of cosines, the following equation is to CB square equals to CA square plus AB square minus 2 times CA times AB times cosine alpha. We only found out that CB square equals to 112, and it equals to CA square. CA square equals to 189 plus AB square. AB is 7, the whole AB square is 7 squared, that is 49. Minus 2 times AC, that is square root of 189, times AB, that is 7, times cosine alpha. So total, according to the law of cosines, in this triangle ABC, the following equation is to 112 equals to 189 plus 49 minus 2 times square root of 189 times 7 times cosine alpha. 189 plus 49 is 238, so 112 equals to 238. Minus 2 times 7 is minus 14, so in total this expression equals to minus 14 times square root of 189 times cosine alpha. So in total, if you found out that 112 equals to 238 minus 14 times square root of 189 times cosine alpha. Here we subtracted 112 from this equation, so we found out that this side of the equation we left with nothing, that is to say 0, while on the other side of the equation we have 238 minus 112 is 126, minus 14 times 100 square root of 188, again minus 14 times the square root of 189 times cosine alpha. So in total, if you found out that 0 equals to 126 minus 14 times the square root of 189 times cosine alpha. Here we move this expression to the other side, and actually found out that 126 equals to 14 times square root of 189 times cosine alpha. Here we divide this equation by 14, if I found out that 126 over 14 is 9, 14 over 14 is 1, so this is the equation we left only square root of 189 times cosine alpha. So total, if I found out that 9 equals to the square root of 189 times cosine alpha. Here we divided this equation by square root of 189, and I found out that cosine alpha equals to 9 over square root of 89. Here we substituted 189 by 9 times 21, so in total we found out that cosine alpha equals to 9 over square root of 9 times 21. Here we took 9 out of the roots, the square root of 9 is 3, so inside the roots we left only with 21. So in total we found out that cosine alpha equals to 9 over 3 times square root of 21. Here we divided both the numerator and the denominator of this expression by 3. 9 over 3 is 3, and 3 over 3 is 1. So this the denominator we left only with square root of 21. So in total we found out that cosine alpha equals to 3 over square root of 21. Here TA is the abbreviation for trigonometric identity. We have the following trigonometric identity that says that sin square alpha plus cosine square alpha equals to 1. So here we subtracted cosine square alpha from this equation, and we found out that sin square alpha equals to 1 minus cosine square alpha. Here we took out of this equation, and we found out that sin alpha equals to the square root of 1 minus cosine square alpha. We only found out that cosine alpha equals to 3 over square root of 21. We squared this equation, So cosine square alpha equals to 3 squared, that is 9, over square root of 21 squared, that is 21. So in total, cosine square alpha equals to 9 over 21. Now we can substitute cosine square alpha in this equation by 9 over 21. We did it, and we found out that sin alpha equals to 1, and cosine square alpha is 9 over 21. You multiply 1 by 21 and then we divide it by 21 in order to have a common factor of this number. So in total we found out that sin alpha equals to 21 times 1 is 21 minus 9 over 21. 21 minus 9 is 12, and so it's 12 over 21. So in total we found out that sin alpha equals to the square root of 12 over 21. Here we divided both the numerator and the denominator of this number by 3. 12 over 3 is 4, and 21 over 3 is 7. So in total we found out that sin alpha equals to the square root of 4 over 7. The square root of 4 is 2, so inside the root we left only 7. So in total we actually found out that sin alpha equals to 2 over square root of 7. Sin alpha equals to 2 over square root of 7, and we only found out that CB equals to the square root of 112 units in its name. The next step, we implemented the law of sines. This triangle ABC. A bit quicker of the law of sines. The law of sines, actually, I already presented to the law of sines, but a bit on it anyway. Again, this is triangle ABC, that could be any triangle. The roof of side AB is C. Side AC equals to units in itself, side B C equals to units in itself. This is angle BAC, this equals to capital A degrees in its size according to our definition. This is angle ACB, this equals to capital C degrees, also according to our definition. This is angle ABC, this equals to capital D degrees in its size. Again, angle ABC equals to capital B degrees in its size. In addition, this triangle ABC is inscribed by this circle. The radius of this circle that blocks triangle ABC is R. So according to the law of sines, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. And again, A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. So we're going to implement the law of sines in this triangle ABC. This is angle alpha according to our definition. So according to the law of sines in this triangle ABC, the following equation is to CB over sinus alpha equals to 2R. Again, CB over sinus alpha equals to 2R. And R is the radius of this circle that blocks triangle ABC. Why triangle ABC is blocked by this circle? Why triangle ABC is inscribed by this circle? Because of the fact that all the 3 vertices of triangle ABC are located on the circle itself. Those 3 vertices are located on the circle itself, therefore triangle ABC is inscribed by this circle. Therefore, we can implement the law of sines. So, according to the law of sines, the following equation is to this triangle ABC. CB over sinus alpha equals to 2R, and R is the radius of this circle that blocks triangle ABC. That is the radius that we are looking for this question. So, according to the law of sines, in triangle ABC, the following equation is to CB over sinus alpha equals to 2R, and R is the radius of the circle that blocks triangle ABC. CB is square root of 112. Over sinus alpha, that is 2 over square root of 7 equals to 2R. Here we substitute 112 by 16 times 7 over 2 over square root of 7. The square root of 16 is 4, so inside the root we left only 7. So 4 times square root of 7 over 2 over square root of 7 equals to 2R. Here we moved square root of 7 to the numerator and 2 to the denominator. In total, we found that 4 times square root of 7 times square root of 7 over 2 equals to 2R. 4 over 2 is 2. So in total, inside those equations, we have 2 times square root of 7 times square root of 7 equals to 2R. We divided this equation by 2. In total, we found out that square root of 7 times square root of 7, that is 7, equals to R. And again, we actually found out that the radius that we are looking for in this equation, that is the radius of this circle, is equal to 7 units in its length. So we finish to repeat on the solution of the first question. The next step, I repeat on the solution of the second question. The second question, our test, let's find out the of this semicircle APQB. So in the north you have a semicircle. This is 9 cm PC, this is equal to 21 units in itself. This is 9 cm PQ, this is equal to 16 units in itself. This is angle CPQ, this is right angle, and AC equals 7 units in itself. Again, our test is to find out the area of this semicircle APQB. So first of all, we define the radius of this semicircle as x. Therefore, the diameter AB is 2x. Therefore, CB equals to AB, that is 2x, minus AC, that is 7. And again, in total, if you found out that this is 97 CB, this equals to AB minus AC. CB equals to AB minus AC. So CB equals to AB, that is the diameter 2x, minus AC, that is 7. So total CB equals to 2x minus 7 units in its length. In the next step, we completed this semicircle to a circle. Then we extended the 7 PC by straight line until it touches the circle. We define the touching point of the extended 97 PC with this circle. This point is point M. We define this 97 cm as A. So we can implement rule 65. Rule 65. We implemented rule 65 in our circle. Rule 65 is for any circle, so this circle could be any circle. So in any circle, if chord AB intersects with chord CD at point O, then the following equation is to AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can actually implement rule 65 in our drawing. Well, because in our drawing, we have chord AB that intersects with chord PM at point C. Again, chord AB intersects with chord PM at point C. Chord AB intersects with chord PM at point C. So therefore, we can implement rule 65. According to rule 65, the following equation is to AC times CB equals to PC times CM. Again, AC times CB equals to PC times CM. According to rule 65, the following equation is to AC times CB equals to PC times CM. So this equation is the implementation of rule 65 in our drawing. AC is 7. CB is 2x minus 7, and it equals to PC, that is 21, times CM, that is A. So in total, according to rule 65, we found out that 7 times 2x minus 7 equals to 21A. Here we divided this equation by 7, so here 7 will get cancelled. 21A over 7 is 3A. So in total we found out that 2x minus 7 equals to 3A. Here we added 7 to this equation. We added 7 to this equation, and finally found out that 2x equals to 3a plus 7. In the next step, we join points Q and M together by straight line. By joining points Q and M, created the right angle PQM. This is a right angle. Angle QPM is a right angle. It is actually peripheral angle QPM. This is equal to 90 degrees inside, and it's subset on chord QM. Therefore, we can implement rule 5. And click on rule 5. According to rule 5, any peripheral angle that is equal to 90 degrees inside must subset on the diameter of the circle. This is peripheral angle MAN. That is equal to 90 degrees inside, and therefore, according to this rule 5, it must subset on the diameter of the circle. Indeed, peripheral angle MAN, that is a right angle, subtend on chord MN, that is the diameter of the circle. So according to rule 5, any peripheral angle that is equal to 90 degrees inside must subtend on the diameter of the circle. You can definitely implement rule 5 in our drawing. One for in our drawing. This is peripheral angle MPQ, that is equal to 90 degrees inside, and therefore according to rule 5, it must subtend on the diameter of the circle. Peripheral angle MPQ subtend on chord QM, and therefore chord QM must be the diameter of the circle according to rule 5. So chord QM is the diameter of the circle according to rule 5. So if QM is the diameter, it means this is equals to 2x, because the radius is x, so QM equals to 2x. So in the next step, we implemented the Pythagoras theorem. on this right triangle PQM. Right rectangle PQM. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right rectangle PQM, QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. But again, this rectangle PQM, according to the Pythagoras theorem, the following equation is true. QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. QM is 2x, therefore QM squared is 2x squared, and this equals to PQ squared. PQ is 16, therefore PQ squared is 16 squared, that is 256, plus PM squared. PM is 21 plus 8, therefore PM squared is 21 plus 8 squared. So total, according to the Pythagoras theorem, from now okay, the right QPM, 2x squared equals to 256 plus 21 plus 8 squared. We only found out that two x equals to 3 plus 7. So there 2x by 3 plus 7. If 2x equals to 3 plus 7, it means that 2x squared equals to 3 plus 7 squared. And it equals to 256, and we have here 21 plus 8 squared. We open the brackets on both sides of this equation and find out that 3 plus 7 squared equals to 3a squared, that is 9a squared, plus 7 squared, that is 49, plus 2 times 3a times 7, that is 42a, and this equals to 256, plus 21 plus a squared. 21 plus a squared equals to 21 squared, that is 441, plus a squared, plus 2 times 21 times 8, that is 42a. Here we have 42a on both sides of this equation, so 42a will get cancelled. After cancel 42a, this side of the equation we left only with 9a squared plus 49, while on the other side of the equation we left with 256 plus 441 plus a squared. But 256 plus 441 is 697 plus a squared. So we should find out that 9a squared plus 49 equals to 697 plus a squared. Here we subtract a squared from this equation, so in this side of the equation we left only with 697, while on the other side of the equation we have 9a squared minus a squared is 8a squared. So in total we actually found out that 8a squared plus 49 equals to 697. Here we subtracted 49 from this equation and finally found out that 8a squared equals to 697 minus 49 is 648. So in total we should find out that 8a squared equals to 648. Here we divided this equation by 8 and finally found out that a squared equals to 648 over 8 is 81. So a squared equals to 81. Here we took out of this equation and finally found out that a equals to the square root of 81, that is 9. Equals to 9. We only found out that 2x equals to 3a plus 7. So 2x equals to 3a. A is 9, so 3a is 3 times 9, that is 27 plus 7. 2x equals to 27 plus 7, that is 34. So 2x equals to 34. Here we divided this equation by 2 and finally found out that x equals to 34 over 2 is 17. So the radius of this semicircle, x equals to 17 means in its length. Our task is to find out the area of this semicircle APQB. We know that the area of any semicircle equals to pi times the radius of the semicircle squared over 2. Repeat again, the area of any semicircle equals to pi times the radius of the semicircle or circle, doesn't matter, over 2. So therefore, the area of our semicircle must be equal to pi times the radius of our semicircle over 2. The radius of our semicircle is x, so the radius squared is x squared. So in total, we actually found out that the radius the area of the semicircle equals to pi x squared over 2. So it is pi over 2 times x squared. X is 17, therefore x squared is 17 squared. So in total, we actually found out that the area of our semicircle equals to pi over 2 times 17 squared. So it is pi over 2 times 17 squared. 17 squared is 289. So in total, we found out that the area of our semicircle equals to either 289 pi over 2 square units inside, or in terms of numbers, the area of this semicircle, that is the area that you are looking for in this question, is equal to 453.96 square units in size. Okay, thank you very much.